Well, folks, it is top of the hour. It is 2 p.m. Eastern time, and we are going to get started on our webinar today. First off, just really appreciate everybody taking some time. The webinar is going to be recorded, and so we can distribute that out after the fact. A couple other little housekeeping items. We're going to save question and answer to the end. So we've actually reserved some time at the end of the webinar to make sure that we can answer any questions that pop up. So in the top of your Teams box here, you should see a little icon that says Q&A. If during the presentation you have any questions, drop them in that Q&A, and we will we'll make sure to address those at the end of the meeting. And so, but anyway, we are super excited to have you for our episode 3 of Scaling Smart, really focusing on the engineering design process today. My name is Chris Fay. I am the president and CEO of Treble-Hook, and I'll be serving as our host and likely the guy that asks ignorant questions of Joel. And then with me is Joel Hanneman. And Joel, I'll let you introduce yourself.
Yeah, I'm the Director of Technical Solutions, focusing on DriveWorks and leading our DriveWorks team at TPM. So we focus on all things integrations and automations with CAD and all other business systems that can surround CAD. So yeah, lots to talk about today. We're kind of we're going to dive right into the thick of it for the engineer in the business and hopefully offer some interesting insights.
Yeah, this has been a cool series for Joel and I to do together. And so, you know, we originally started this thing as a multi-part series where we talked about, you know, really specifically configurable product manufacturers. We talked about how to solve, challenges and why the challenges exist. And then we've done this really 3-part series with a 4th part forthcoming. So Joel, why don't we take a step back just very quickly? I know today we want to dive into the details, but it'd be great to just do a quick step back on kind of the previous episodes, just to remind folks what we talked about, or if they're new to the call today, just a level set on the same page.
Yeah. So at TPM, we engage with all sorts of businesses, given our various divisions that we have. This conversation, this ongoing conversation across many episodes has really been geared specifically for manufacturers. And we've been focused even more on manufacturers that design and produce configurable product. So the kind of operative word there is configurable, and that's the adjective in the description here that has carries the most weight to it. And so throughout our series, and we'll kind of pick on this a bit more, is what is configuration? Why is that a thing? Why does that impact a business? In the first 2 episodes, we focused on business level considerations for this type of a business. And then we pivoted to sales. Now we're working our way kind of downstream in the business, and we'll end up with engineering today. But yeah, back on the note of configurability or configurations, it just simply adds more complexity to running a business. Every step along the way in running that business is further challenged by the nature of configurability. So it impacts everyone throughout the business. And so today we'll kind of study why that's the case for engineering. Yeah, and so if you've been on a few of the other episodes, the story might sound pretty familiar. When we broke down the issues involved in the sales perspective of configurable product, we came to some conclusions, and I think we're going to come to the same conclusions again today. So it's interesting that the story doesn't change a whole lot as we go from department to department. It's the same core story, just told from a different perspective, different details, different sub considerations. But at the end of the day, the nature of configurability just has the same underlying issue, which we broke down to be really all about managing data. Okay, with the key point that it really doesn't matter what your business makes, if it's capital equipment or widgets or bicycles or boats, whatever goes out the back door, that might be unique to you, but you've got to manage data and do that well, just like everyone else. And so, in prior exercises, we went through, okay, well, you might experience this type of challenge at a business level. If you chase that down, to its root cause is probably going to have something to do with data. And we got to, at the end of the day, we're talking about putting data in the right hands at the right time.
And Joel, I know that one of the things we talked about, last time, just generally around taking, how to configurable products, scale their business at a more rapid rate or improve their profitability. And I know we recap just all these breakdowns and, talking about in sales, the cost of having the wrong data in the business and the time spent on managing the incorrect data between customer and sales or sales and engineering or engineering and manufacturing. And so it was a great conversation we had just in this, kind of configurable space of how many opportunities there are for potential breakdown in data. And if you could really streamline that, right, you've got the ability to scale your business at a more rapid rate, to take on, more sales quotations, to be able to save more time and to go to market more efficiently, and then ultimately ensure that the people that are making the products and manufacturing, are making it right the first time when it goes out the door. So I think all of this really ties back to, growing your business and making it more profitable. So,
yeah, and I think we are definitely blessed with a great customer base. I guess that's evidenced by the fact that whenever we engage with a customer, the story is generally something like, we have plans to grow. We want to grow 5x in the next 3 years, this and that. No one tells us, hey, we're looking for a nice flat year next year. That'd be great. Or we're going to try and downscale our business, right? No one has the goal of declining, right? Everyone, I would like to think, has the goal of scaling. Fundamentally, you can't scale, or it's not a good idea. It's not going to work out to scale something that's not ready for it. Right? Analogy, a beat up pickup truck with an oil leak and bad brakes and the steering's off. It might get you out the driveway and down to the store and back. But are you ready for the highway? Are you ready to cut across the state borders in that beat up truck? Probably not. So we really got to identify all these areas of a configurable manufacturing business that really need to be targeted before attempting to scale. So, yep. And then kind of the final layer of the conversation is like, all right, now that we understand that data is kind of at the core story here, what am I to do about it? If I'm a business leader, how do I hadn't really thought about this much. Like where do I even get started? Okay. And so we're not going to rehash it today, but talked about the value of process mapping, just simply taking the crude step of dumping your business onto a whiteboard or piece of paper, just map it out, make it visual. Usually that mapping exercise goes a long way to kind of informing next steps. Okay, this concept of root cause analysis, I don't think will be new to anyone. I think we all probably do it all the time in our lives, but it's fundamental to ask why enough times till you get to that real answer. You've got a challenge, you've experienced the challenge, but what's the core problem? That requires really digging in. Okay. Like any business is going to have multiple battles to fight, multiple fronts of improvement. Can't do it all one time. Project management 101 says, identify either the most achievable gains or the most valuable gains. But we generally recommend get some small productive wins early. Nothing like doing that to build momentum throughout the company and just foster that effort for the long haul. And finally, and then what we're going to get a piece of today is actually talking about technology. Technology is out there to help businesses like this. Okay. So the problems that you're experiencing, you might think of, maybe never occurred to you that there's another way to look at these types of issues. So, all right, Chris, any other thoughts on where we've come from?
No, I think it's great. Yeah. And I think the prioritization was a great topic we had last time of just how to, it's hard, especially when we analyze our businesses and we map everything out and find the root cause. We really want to attack, each and every pain point at one time. And to your point is, what is the one thing that I can do maybe in the third quarter or the fourth quarter of this year to start making progress? So no, I think it's great. And I think, what we talked about today is really now mapping into, we talked a lot about sales, right, last time, and now really kind of getting into the design and engineering space where the core CAD data and data exists. So yeah, let's kind of transition and talk about some of the top challenges, Joel.
Okay. All right. So no surprise, we're going to talk about the nature of configurability again today. it rears its head everywhere in the business, and engineering is no exception. So let's unpack that a bit. I think of a lot of our customers that I work with pretty closely, their product or their items. You could just say their SOLIDWORKS assemblies, however you want to conceptualize the product, can have anywhere from hundreds to even thousands of data points that define them. I think we spoke about a door manufacturer that we work with that to design a single door, there are 5,000 pieces of information that have to be addressed somehow, some way, right? And so that's just really speaking the volume of considerations and the number of things that have to be right. Right? If one of those 5,000 pieces of information is slightly off, well, when that door arrives at the construction site and they go to hang it and it doesn't fit, well, it turns out that one piece mattered, right? So just straight up configurations compound the amount of information that has to be managed, dealt with, ensured is correct, right? So now what connects those 5,000 data points or so? I would refer to that as design intent, right? That you have a door width or door height, or the lock is in a certain location with respect to the door face. There's reasons for all those values, right? The engineers or designers aren't just picking numbers out of thin air. It's all based on logic. It's all based on rules. It's all based on some form of company know-how, right? So the key thing to consider is, where is all that know-how? Go find that know-how and point at it, right? Is it in a binder? Is it on your hard drive? Is it on your website? Is it in a catalog? Or is it nowhere, literally, and it's just in the team and the engineering team's heads, right? That's probably going to sound very familiar to a lot of people that are listening in. Is like, yeah, we are very reliant on what's going on up here, and especially the veterans that have been around a while, seen it all. They are the only ones that know how to synthesize all this data and make sure that the end result is what it needs to be. Okay. Third thing that really doesn't help the configuration picture is that just about any business system out there is just not suited for configurability. Software at its core tends to be designed to handle certain tasks. Those tasks, you can draw a box around them. The software company delivers a solution that fits inside that box. Use it or not, right? That's kind of like the general approach to software, or at least has been historically speaking. And even SOLIDWORKS, our favorite CAD software that we work with, has some tools that help with the idea of configuring, but still falls short a bit. So even your CAD system, which you might interact with all day, every day, still isn't perfectly suited for that. So anyway, we just have this technology layer that to date or historically hasn't been a great part of the solution. All right, so that's kind of the nature of dealing with the design process itself. But what's the environment that heavy exercise exists within? Okay, all the forces acting on a business hopefully come from the customer, right? All of our customers we know are needy. They want it all. They want it now, and they are correct, right? And so you either accept that and make the most of it, or probably don't have a whole lot of happy customers. So what does that end? How does that manifest itself? Well, they're going to change their minds. They're going to have revisions. That 5,000 data point door, that thing isn't going to get produced until after a year's sales cycle, in which there may have been 10 revisions, right? So not only do we have a lot of data to define a single door, but now we have 10 revisions to manage along the way, further compounding this whole data problem. Okay. Oh, by the way, the customer, like I said, wants it yesterday. So not only is there a lot to deal with, but there's a time pressure applied as well. Not the best combination. Way too much to do and not enough time to do it. You know where that type of combination goes. Okay, now let's actually think real hard about what we call the work that satisfies all of this, okay? And just because it happens within the engineering department in a business doesn't mean, and I kind of synonymously use engineering and design and drafting. That's all kind of like one bucket in the business. But that part of the business, when you break down the actual work at hand, how much of it is actually engineering? How much of it is like new, novel, creative design? How much of it is moving the product and the company forward in some new and different way, as opposed to just rehashing information and insights that are all in the past, right? So often dealing with repeatable, predictable, maybe menial is not the right word to use, but like, just not human ingenuity type thought process along the way, right? So I think we can all agree that that's not really engineering. Doesn't take advantage of that engineering talent. And frankly, I was an engineer in school. If someone told me that my job when I graduated was just going to be to tune up 50 drawings a day, save them as a PDF and DXF and email them out, I may have chosen a different profession, right? Because that doesn't sound very interesting, right? So not only do we have too much to do, we're under pressure to do it. And oh, by the way, the things that we really need to do are kind of silly to begin with. They're just manual, time consuming, error prone, etc. Right? And the icing on the cake, the engineering department is where that's the last buck right there, the last car on the train, the end of the road. Okay, once it gets past that department, we're talking manufacturing, and that's where the real problems start to manifest themselves in ways that are quite real to the business. Engineering has their own challenges, but once it gets into manufacturing, that becomes a company-wide problem that actually starts costing money. So not only does the engineering group have to deal with everything upstream, but if they don't get their part right, then real consequences come after. Right? So I don't know. Hopefully, Chris, I'm not scaring people away from the engineering profession.
No, I know
a pretty bleak picture here.
Yeah, wildly rewarding. But honestly, I think I talked about this with somebody yesterday. Is that engineers and we all want to spend more time doing what it is that we love, right? And I think that when an engineer is able to actually do the design work and solve problems, those are the things that they love to do. What they don't love to do is this back and forth and these trying to chase things down and the pressure and the manual inefficient work. So if anything, I think that it's encouraging to think about these are the challenges that our engineering customers don't want to experience. And so if there's a way to get rid of them so they can spend more time doing what they love, it's a win.
That's right. That's basically what it all comes down to. So, all right. So that's how I interpret the challenges out there. It's kind of lightly characterizing them. So now let's move on to all right, well, if we were to do better, what does better start to look like? Okay, so let's start thinking about solutions. What engineer doesn't like a good solution? So, and in this, and by the way, we're going to get to a demo later. I'm not sure if we shared that. So there'll actually be something kind of cool to look at and something real. And that's coming shortly. But even with that, I don't want to focus on any specific technology or any specific solution today. We're really just trying to characterize how the future could look and kind of put our finger on specific things that we could do better. And just let's exit today's conversation just saying, all right, yeah, I get it. There's solutions out there. We should probably look into them, but let's start doing some homework. But we're not going to dive into too much detail today. That being said, the first concept that we have to really wrap our heads around is just making sure we understand what design intent is and what institutionalizing design intent is all about. So design intent is, I talked about those 5,000 data points in the door and how those aren't just a bunch of random numbers. They're all there for a reason. They must be just so. Well, that's the result of design intent. When a door is so wide and is rated for fire and you got the handle over here, a lot of things matter, right? That all this information cascades into the exact, precise design that's going to satisfy that need. Design intent. I think we all get that, right? So, all right, how do we institutionalize it? Well, in the most simple way to describe that possible is let's take it from everyone's minds or the spreadsheet or that binder or wherever else this this stuff lives and put it into one place, situate it. Oh, and let's let that one place be a piece of software, right? Technology is here to help after all. So once you have all this information in a single place, at least it's now something of a single source of truth, and you can start to look at it all at once and make it actionable, right? Then you can start to exploit it, utilize it, put it to work. If that design intent is scattered all over the place, then how do you actually use it, right? So that's one big thing. So with all that intent in place, I think if we're all here because we have something to do with SOLIDWORKS or model or do CAD as part of our work lives. So let's take advantage of, I like the word exploit, all that intent with an eye towards automating, right? And especially automating anything that's repeatable, predictable, based on logic, prior know-how, takes a lot of time, is annoying, you do a lot of, all that. Like that's all ripe for automation. So let's take advantage of that design intent and put it to use just like that. We already talked about, what does an engineer have to look forward to when they don't have to do all that stuff anymore? Well, the good stuff, right? Focus on ingenuity, novel, new things, so on and so forth. All right, so zooming out a little bit, engineering is just one department of many in the business, and they don't work in a silo, right? They have to interface with sales. They have to send bills and materials information to ERP. They might have to prepare drawings for the quality department. They might have to, who knows what, right? They don't just work in their little box and that's it. There's other things out there in the business that they have to participate in. And really what I'm getting at is like, let's start thinking about how do we integrate? How do we prevent duplicating information, entering information again in a different system, having to translate, coordinate. Oh, I take my Excel, SOLIDWORKS BOM, export it to a CSV, then I doctor that up, and then I email it to someone who uploads it in ERP, then they fix it there, like all that kind of stuff. No, that again, that's nothing more the same. Repeatable, predictable, menial, repetitive tasks. It's just kind of one click outside of the core engineering work. And just now we're just talking about the interface between engineering and others. Okay. Now taking that concept a big step forward is, well, hey, if we can automate engineering, if we've got all of our design rules in one place, does engineer have to do that anymore at all? Like if we situate all this intent and put it into a salesperson's hands, can't they configure the product themselves? Or why can't the customer do that? Or your distributor, right? So the point is that what we think of as engineering work, which we just belabor the fact is like usually not engineering, it's just information shuffling. Let's think of that as not even being engineering work. That's just stuff that technology does, and well, let's let people have a self-serve basis for accessing that. So that's kind of like next level thinking is just if you can think about redefining what engineering really means, offload the rest, then that sounds like a pretty compelling solution. So that's kind of the rundown of what I see as the challenges and how I would start to look at solutions. So Chris, how does that sound? Does that sound familiar to you? Is that kind of, you run a business, do you kind of look at running TPM in a similar way?
Yeah, absolutely, man. I mean, I just think about all the teams. How can we make sure that our teams across the business are doing the highest and best use of their time and working with one another, and looking for ways to leverage technology to automate processes so that our people can do more, and connecting it through the entire life cycle through the project. So I think it's great. Yeah, I'm excited to kind of see what you got to show, Joel.
Okay. All right. Yeah. So let's move on to some examples of this in real life. So I'm going to have to switch my screen here. 1 second. Let's see. Share. There we go. All right, Chris, can you see my screen here? I've got a
Yep, I got you on the configuration page. Yep, exactly.
Yeah, there we go. Okay, so We're going to look at some product configuration solutions, just straight up. Now, this might be different than anything you've seen or experienced before. This is going to be perhaps a collection of technology that totally unaware of. And so I'm going to take a little bit of time to explain what we're actually looking at. So I'm sharing my screen. This is my web browser. Okay, right? So I'm just on a browser. I could be anywhere in the world. I could be anybody in the world. And I'm just going to log in. Always got to think about security, so we take that pretty seriously. Let me grab my password real quick.
And I've already asked Joel how he has his browser tabs on the left-hand side. So he's a Firefox user. I've already learned that. So
yeah, I love my Firefox. I've got containers to organize all my tabs. I kind of geek out on that. I even have my AI cheater right here. I click on that thing all the time. Anyway, so this is a website that we host through our automation team. We have it for demo purposes and to help explain concepts to our customers. So we're just going to kind of use this resource that we've used many times before. So we've got a couple configurators that we'll walk through and do a compare and contrast along the way. So let's start off with this shelving demo. So it's a demo. Let's be clear about that. It's not a full-fledged real-world implementation. It is. Well, there is a real-world implementation at the root of it, but it's been dumbed down, stripped down, just simplified for easy consumption for moments like these. Okay. So a hypothetical shelving company, right? They sell to Amazon warehouses and manufacturers, whoever needs shelving in a warehouse. This is their business. Now, first and foremost, what are we looking at? I'm spinning this room around in 3D. That's pretty neat. No, this isn't SolidWorks in a browser, but it's pretty close. Okay, and so what we're going to notice first, we haven't even started designing the product, and we are contextualizing the configuration moment in the final state, right? So how much better is it to see the product come to life in the context of where it's going to go to really give that rich configuration experience. So now, I don't know a whole lot about shelving. Yet by the end of this, I'm going to have in my email inbox fully defined SolidWorks assemblies, drawings, PDFs, all that stuff for the shelving product that I'm about to design and did not exist before this moment. So I can specify my room dimensions if I want, right? That's kind of neat. All right, and then I get to, at a high level, describe what I want out of my product. Okay, and like this little piece of UI or not, I just want to talk about what we're actually experiencing here. So configuration 101. We're going to use UI. UI is user interface, the form, to communicate in real time to someone who doesn't necessarily know what they're doing, me, about how the product works. Okay, so we're going to see if I pick a heavy duty shelving system, hold on. Let's see. If I want a light duty shelving system, now MDF is an option for the shelf. If I want a medium duty, plywood's an option, right? So we have our first occasion where we have design intent, two pieces of design intent, if not three, that are kind of coming together, marrying together. You can think of these as caveats, or you might think of this as a design tree where you answer question one, you go down here, you answer question two, you go down, so on and so forth. That's all on display. It's just in a manner that is kind of visually appealing, right?
And Joel, I can just imagine, a salesperson, especially somebody new in the organization, needing to learn all the various configurations, right? And coming to engineering saying, hey, I need a chipboard, super light one, and engineering coming back and saying, hey, we don't even make that. Go tell your customer they're crazy. So, obviously this helps kind of guide to make sure that the initial information that's going out the door is accurate.
Right. Imagine if that's Rev 1 of right. 10 more revs, how important is that to do better and better every time, right? So you probably don't know, I don't know. If you want casters on your shelving so you can move them around easily, can you, does that satisfy with the steel shelves? If I pick, no, turns out I can't. That's not an option, right? So it's so easy to tell what's an option, what's not, what's the right combination of settings, so on and so forth. Just basic UI on display. Okay, so from here, we're going to have an interesting approach where we're going to use the mouse to design, right? So no longer is a customer going to communicate over the phone to a salesperson who's going to take some notes, pass the notes off to the engineer who's going to try and interpret the notes and do some stuff in SolidWorks to produce an outcome. No, we're going to skip all that. Instead, let's let that end user just use their mouse, a little bit of keyboard, and design the system that they need, right? All in real time with tremendous feedback, right? See how the graphics are changing as I change my needs, right? If I change the number of shelves, like all that's there, right? And so if I change from 5 shelves down to 2, that's cool. If I change my height, not sure if you noticed, but the number of support brackets change, so on and so forth, right? So every single piece of design intent, I don't know how many data points there are for this unit. There could be a couple thousand. Those are all baked in. It's all happening behind the scenes thanks to technology, right? All that really needs to be done is the user supplies some inputs, clicks a few buttons, they're happy with what they want, we're done. Now we could keep adding more and more, right? So that we just designed a single instance of the product. But what if we want a system's worth of products, right? And what if each one of those items in the system are unique in of themselves? Right here on display is the nature of the problem of configuration, just right here in front of us. One line item, 2 different things. We just doubled the amount of data, just like that, right? And we can keep going. We can have a full warehouse of this shelving. Each one of we is unique and has its own couple thousand data points, right? Okay, so let's go ahead and angle that thing because, hey, why not? And call that. Now, we can keep going, but let's get to actually this automation bit. Okay, so I'm going to fill in some information here. And before I hit the proverbial go button, I wanted to show you that something else. Okay, so I just flipped to, in this case, it's an Azure VM that I'm remoted into. It's a SolidWorks machine, just like any of the engineers here on the call have SolidWorks on their laptop, or maybe they're running it through a server in a data center somewhere. Doesn't really matter. SolidWorks is SolidWorks wherever you want it. You can have it there. In this case, it's fully in the cloud. But just know that this is somewhere different than me as the user in the browser. Right? So what's going to happen? I'm going to hit submit. My friendly website is going to keep me updated from the user standpoint. And just like that, we've got all this automation we've been talking about. So no human hands, yet the CAD's cranking along. Every part, every assembly, every drawing, every feature, every dimension inside the feature, every pattern, I'll just say it this way, if you can do something with a mouse in SolidWorks by hand, that can be automated. Every single data point, in this case, let's estimate 4,000 data points are being processed like that, taking advantage of all that design intent that's been institutionalized inside the technology and is off and running, right? So let's say I'm a distributor of the shelving system. As far as I'm concerned, I'm just looking at a website, things are being produced. Hey, there's that one drawing I need. Oh, here's that custom shelf that's going to be needed, so on and so forth. These things are happening in real time. As the user who doesn't know anything about CAD, I'm privy to these types of insights. And as the content that's appropriate for me becomes available, I'll have direct access to it via this website or via an email that's forthcoming. So we'll circle back to SolidWorks. It might take a little while. It might take a few minutes, but a whole lot quicker than human hands doing it. And 0 errors along the way. So Chris, what do you think about that?
Yeah, it's pretty awesome. I mean, absolutely. You think about like all of a sudden this comes through, an engineer has to go through and just redraft something they've probably drafted 100 times and then sending it back for approval and making sure it's correct. I mean, so yeah, this in my mind allows the engineers to focus on designing the new products and ensuring some general QA, QC. But yeah, it's pretty awesome. And this was actually one question that popped up in our last webinar that we did, kind of the series 1. And there was some questions around, okay, this is awesome. Like, where do y'all fit in this? Where does TPM fit? And what does this process look like? So obviously, you're seeing SolidWorks, right? Which is we're obviously a partner of SolidWorks and DriveWorks, but SolidWorks that everybody knows and loves, and then the product DriveWorks. And there's a configuration that you have to do to get all this stuff set up, to Joel's point, to get that institutional knowledge in the system. But once it's in the system, the ability to execute like this, and that's really where we come in, and is to help make sure we're gathering that institutional knowledge and building it in the system. But yeah, Joel, I can imagine if I'm a distributor, I'm putting in a bunch of specs, it's automatically creating the documents, the drawings, and I'm sending that over to manufacturing for production. I mean, it is massive amounts of time. I can imagine how long this would normally take.
Yeah, and here's how the story usually carries on. As soon as I get my drawing, like, oops, that dimension's not right. Hold on, let me add another unit to that bay. And how would that traditionally go down? Back to the salesperson, back to the engineer. He has to redo the work, send it back upstream, and that goes on and on and on, right? So in this case, if I realize a mistake, I can go back and fix it, click the go button again, no harm, no foul, right? So as I've described in the PowerPoint part, this is a great representation of how there's opportunity to rethink what the engineer does, right? Is this engineering work? Not really, right? We're just taking values, plugging it into another piece of software, saving some files on a network, and emailing the files out. None of that sounds like engineering to me. So I think there's a lot of opportunity. Mm-hmm.
Yeah, Joel, the other thing I think on top of this is just generally the costing as well. We talked about the costing up above, and how much is this is going to cost. And so, obviously, if we're taking, financial information from our ERP system and plugging that in, the costing exercise, because I imagine to some extent a configurable products manufacturer, the salesperson might need engineering to potentially design something in order to get a proper estimate out the door and then sent back to sales. But if we're leveraging financial information from ERP, really the salesperson is able to continue to configure, provide the pricing, also have the engineering documents, and then that passes through from kind of QA to QC on the design side.
Yep, that can all blend together, and that's getting into the integrations that we were talking about. So here we have an example bill of materials. Yeah, perhaps this bill of materials was synthesized against a quick grab of material costing data in ERP. Maybe had to go and look at which customer this is in the CRM, check out what discounting they are afforded, do all that math just to, in the nick of time, produce a quote with an actual price, the tax information, the shipping information, all of that. So that's not just an engineering domain issue. That's now having to integrate the whole business's worth of insights to produce a single deliverable, again, without human hands. So that's one example. It's plugging away here. We can see that finally we got like an assembly level drawing showing exactly what I picked and clicked my way through to achieving on the website. Here it is in a real physical sense, ready to go. All right. So that's one example. And I said I wanted to show another one to compare and contrast. What's going to be...
And Joel, just a time check. We got probably 5 or 6 minutes left in this. So I think, kind of carrying that concept, we can show this one and then maybe pivot over to Q&A.
Yeah. So what's going to be the same thing about this demo is at the end, SolidWorks gets generated just like it did before. So we don't really have to zero in on that, but I just want to show a different flavor of capturing the idea of configurability and another flavor of institutionalizing, right? Because those are such key points. We're just going to see a totally different way of approaching that, just to say, hey, there's more than one way to do it. So this product here is industrial grade HVAC equipment. You'll find it on the top of an Amazon warehouse or the Ford factory, right? Like big gear, right? Perhaps 100 feet long, tens of thousands of components in the bills of materials. Definitively needs to be different for every factory that it's going to handle. This is just a larger scale issue, a whole lot more data, right? And actually, in some ways, a bit more complicated too. And so that's what we're seeing here on page 1 is you can imagine. I mean, you don't know much about HVAC. I don't either. But airflow, like the amount of air that this system is supposed to account for, if this is a metric, but if it's 3 versus 30, in other words, if it's an amount or 10 times more, you can imagine that the fundamental characteristics of the system will have to change greatly. The fan choice, the motor specs, how many filters, is the enclosure 10 feet or 20 feet? All the way down to, do you need 15,000 washers or 8,000? Just one single choice can cascade in a way that impacts so many other kind of sub choices from there. And those are the caveats galore that most people worry about. That's the type of stuff that your sales force probably just won't ever have like the best feel for, and will continue to rely on you or rely on that veteran engineer to really pull it all together. That's on full display here. Okay. So anyways, I'm gonna max it out at 30. This is a big unit, do a lot of things. And what this system is going to allow me to do is design, as soon as I put an entry unit on, from here, I can, in a very modular way, design one chunk of this system at a time with guardrails. So, okay, let's say I want to add a filter first. That's on me, right? This system's kind of trusting that I know enough about how to put the system together, so I can make some basic choices about that. But everything about this choice has been influenced by that first choice of capacity. And you can imagine a 3 CFM filter versus a 30 CFM filter, very different things. We're just going to simplify that for the end user, however, and distill it down to 2 basic choices. And of course, you can see we're doing pricing in real time. We've got annotations throughout that kind of help key the user into just giving them more and more feedback to give ever more confidence that they're making the choices that are right for them, right? So I can keep going, right? And what's really interesting about this demo is you can add more and more and more and more. There's no limits. You can have 100 modules long. That's how configurable this one product can be. So it can go from 1,000 data points to hundreds of thousands of data points, all interrelated. We have to have system level factors that marry up with individual component level factors, and all of that has to just synthesize perfectly to end up with just the right result in CAD so that no one has to touch it. So I think this is just interesting because it's just a great example of an ever more complicated product. And so, yes, we can deal with complicated. We're pretty used to doing that. Okay, so I'm just going to go and finish this one off. Confirm, kind of go to the same thing, just do a quick screenshot to show you that things are happening in SOLIDWORKS. I think to generate what I just requested is going to be maybe 5 or 10 minutes. So we won't have a chance to like watch it go through all the way. But hey, 5 or 10 minutes is a lot quicker than hours or days that it would have taken manually to do the same thing. So, all right. So there it goes. It's off and running. In my inbox, I'll have a complete file set for this unit. No human hands.
And Joel, I know we've had some situations where, depending on the front end interface, whether it's a customized app that somebody wants to provide their salespeople, whether they want to leverage like Salesforce.com, for an interface, tying into various ERP systems. I mean, I think what we've seen is that you've got the core engine of SOLIDWORKS data and this back-end kind of DriveWorks automation tool, but the ability to surface it and connect to virtually any system that's out there. I know we're doing a lot of work in the Salesforce space, and then this kind of connectivity on the ERP space. And so I know that's just been something I wanted to throw out there. That's been a question in the past is this exclusive to, a couple of different types of systems? And the reality is you have this engine that can ingest data from a multitude of sources and also display data to a multitude of sources. So Joel, it's awesome. And we're right, 2:45. And so I think, let's maybe take a couple questions, and then maybe we can close this out and get everybody back to doing what it is they do best.
If I could just touch on what you just said, Chris. I mean, you position SOLIDWORKS as kind of the middle of a bigger software / business ecosystem, which that's one and the same as saying configurable product manufacturer, right? You don't sell configurable product if you don't design in CAD, right? I mean, that's just such a thick, it just is what it is, right? So, most businesses wouldn't look at themselves and say, the heart of what we do is our design work. But actually it is. Because it wouldn't exist, it wouldn't be machined, it wouldn't be shipped, it wouldn't be sellable if it weren't actually designed every time, right? So I think maybe the way to sort of reinterpret looking at improving the business as a whole is saying, hey, this is our core, this is our heartbeat, and everything else is an extension of it, right? Including possibly ERP. A lot of companies think of ERP as being the big kahuna, the end-all be-all piece of software that everything else kind of has to coalesce around. Well, that's often not the case for this type of manufacturer.
Right. Awesome. Love it. Let's take a couple questions for the audience and see. I'm going to pop up our Q&A here, and our DJ Mackenzie is going to help us kind of filter through and provide any questions. So Mackenzie, what do we have on tap for everyone here?
Yeah, really great question from somebody asking. They said their product has thousands of data points, and it kind of sounds like a lot of work to get this up and running. What's the reality of institutionalizing something like that?
Leave it to the engineering group to really dive into the details and want to know everything in the first meeting. No, that's good. No, we'll go there. The reality, yeah. So we're not talking about magic. Okay, we're not talking about waving a wand over your business and all of a sudden things just work better, right? And so to reach a future state of automation that you're seeing that we put on display today, there's some work there, right? And the way I've come to think of it is that the technology that you put to use to achieve the automation, you can think of that as being a mirror of yourself, of the business, right? So if your business is complicated, the technology itself won't be complicated, but it will have to handle complicated things. There's no way about that. Technology won't magically simplify things all of a sudden. So there's no cute sales answer to this saying, oh, it's just really easy and it takes no time at all. That's not the case. But what I can say about this technology is that it's if you don't put it there, where else will you put it? The business has been going on for how many years without anywhere to put it, and now there's a place to put it. So that's kind of the positive spin on that question is it's going to take as long as it takes. If it's tens of thousands of pieces of information and rules, then those have to be created and institutionalized, and there's no way around that. But once that upfront work is done, you see the results.
And Joel, I would imagine, for a configurable products manufacturer, there's lots of different products that they might have as well. And kind of going back to our statement before is thinking around, mapping out the process, identifying the root cause, and then starting to prioritize where you attack. Is that this is a journey, not a destination. And so you look at like maybe what's the product in my business that ends up having the most issues or the most rework, or what's the product in my business that we sell the most of and have to spend the most engineering time on, and potentially attacking that and then continuing to kind of move through that ecosystem. But Joel, I know the last time one of the questions was just in general. I know this is a loaded question, but to go from nothing to I'm now at least configuring one product in this. I mean, I think we were talking the last time around, you're talking about weeks to a few months, not years. So,
right.
As you think about like implementing something like this in your business, this isn't like a multi-year millions of dollars implementation. You can start making substantial impacts in your business within early few months, and then lean on that technology to do more and more for it. So I know that was one of the concerns that popped up in our last conversation.
Yeah, no, it is a journey, and the success of that journey is in a large part based on how well we can take it one step at a time, right? Let's identify something achievable, perhaps even within days, right? Let's get one of those sub-assemblies going, right? Learn from that, experience it, sprint to that result. start the next one, sprint to the next one. And then, like you said, weeks later, you might have quite a bit done, right? But you got to start somewhere. Start small, start in a way that's achievable, and embrace it as a journey.
Yep. Awesome. Mackenzie, what else we got?
Yeah, one more kind of on the opposite end of the spectrum. This person's asking, my product doesn't have a lot of data points, but they're very complicated. How would you deal with that?
Yeah, I think we're getting back to the concept of caveats and exceptions. And, if we're designing that HVAC system and it's got to go to Florida, well, if you're sticking something on the roof, there's hurricane wind rules. And if it's going to Montana, it's got to withstand the snow load. And, some local municipalities have different building codes for what a roof can support. I bet it goes on and on and on. Right. And again, that's just the reality of your product and the environment in which that product is sold and delivered. So I think what we're doing is we're exchanging the sense of volume in the first question and just exchanging that for just straight up complexity. Right. We're exchanging a breadth of a solution and pivoting it to look at like the depth of how that solution is enabled. The short story is there's so many ways to capture that kind of information, various ways to capture database data or logical data. Without like giving you a real back-end tour of how this type of software works, it's a little hard to describe fully, but I'll just say right now, that's not something that we are all that concerned about. There are ways to handle layer upon layer upon layer of complication, have an exception anywhere in there and just activate that.
Yeah, it's just mapping the whatever the inputs are to the outputs, right? And then documenting it.
Yeah.
Joel, one last question.
Sorry. One more comment. Something I keep coming back to on that complication thread is if you can explain how it works in plain English, then that can be dealt with. Right? Just say it in a sentence, write a paragraph. How is it supposed to work? That's the hard part, right? Once you can do that, putting it into the software is actually the easy part.
Just dictate it in ChatGPT and have it, put a recap before you.
Not too far off. Yeah. I mean, at the end of the day, that wasn't actually a software question. That was how do I assess my own design process question?
Right.
If you can map it out, if you can write it out, then the software is the easy part.
Yep. But Joel, I guess last question I was going to just ask, and if maybe for the group is, obviously you get this thing spun up. But hey, now you need to make changes, right? Like there's this configurable product has gone through an upgrade, and now there's some dimensional shifts or some inputs. Just what's our ongoing ability to manage changes that might occur in some of the design or some of those inputs?
Yeah, I mean, pretty typical in the world of software is, everywhere in software there's constant development, right? There's not one use of software out there that's just static, set it and forget it. So how do we deal with that within the industry? Well, you tend to have a production environment, right? That you're using on a day-to-day basis. Meanwhile, you might have a staging or test environment and even like a dev environment, right? So yeah, your latest current state stuff is in production, but you're always working in dev, making some changes, testing those changes. Once you're happy with it, push it into that production space. So that's just a kind of a fundamental principle of developing in software, and we embrace that fully. And there's tools for doing that pretty easily.
Awesome. Well, I guess before we close, Mackenzie, anything else on there? Or was that the last one that popped through?
That's all we got.
Awesome. I know, Joel, we covered a lot, and just a couple parting thoughts on my side. I'd love to kind of hear, from you as we close in the next couple of minutes. But, I think generally, number one, I don't think that a lot of folks realize that this technology exists and can be so quickly and easily deployed. And, taking core technology like SolidWorks data and this DriveWorks engine and connecting to other data sets. And it's really the biggest barrier in my mind is that, these configurable product manufacturers are doing a great job. They're wanting to grow, they're wanting to learn, and oftentimes there's a lack of visibility or awareness that there's a better way to do it, right? And so hopefully today is just opening your minds that there is a better way to do it. And obviously it takes investment and time and resources and money to put this in place, but the ROI is so significant to help you have your engineering team spend more time on what it is that they do best, to reduce the errors inside of the business, and then ultimately to develop a platform for scale to take your business to the next level. So I know super exciting every time we kind of go through this, Joel. It's just awesome to see some of the things that we do. And then I'll just say, a quick overview again from where TPM, where Joel and my organization fits, is we guide you through this process, right? So we talked about the process mapping. We talked about the root cause analysis. We talked about, prioritizing and then implementing a deployment. That's where TPM's organization comes in. We actually will sit down with you and map your process out. We'll identify the root cause. We'll help you prioritize. And then our team will then take that and create the DriveWorks ecosystem, all the automation and everything that you saw today. We actually do all that work for you. So, if you need help, if you have a challenge, don't be so concerned about how you're going to get there. That's why we're in business, and that's why so many customers are leveraging our resources, as we really are here as a guide to help shepherd you through this process. So, and then I know next time, Joel, we'll kind of dive a little bit deeper into the manufacturing aspect of this next month. So any closing thoughts on your side, Joel?
Yeah, no, just circling back to that word scaling, right? That's what this is all about. And that's the why behind this whole conversation. In fact, when we hear from our customers and they say, hey, we intend on tripling our business in 5 years. That sounds great. A lofty goal, a good goal. Hey, you're going to triple your engineering team too? Probably not. You're going to triple your sales team? Hopefully not, right? So fundamentally, to achieve scale, somehow, some way, we all have to learn how to do more with less, or at least more with the same, right? So, the tripling the business is going to happen overnight, nor is preparing to do that. So, if you're serious about scaling, you got to be serious about the journey part of this, and really have to identify what's going to get in the way of scaling. And if it's fundamentally dealing with data, getting hung up on moving information around the business and getting hung up on all these manual tasks, then how do you scale that? The answer is you can't really. So, I think also what's interesting is these days, AI is on everyone's minds. AI is kind of maybe an analogous conversation, and everyone's wondering, well, how's that going to change work? How's it going to change how our business runs? What is that going to mean for my job later? I'm not trying to say that automating engineering is like a threat to an engineer's job, but I bet you're already thinking at some level, what can I do to make me more productive, make me more valuable, make what my department does more valuable to the organization? So I think this is all one big conversation. We're all figuring out how to do it.
Yep.
So,
well, folks, we're at 3:00 and we agree to get you out of here within an hour. And so thank you again for your time today. This is recorded in case you want to share it across. And then if there's anything that the TPM organization can do to support you all in your growth journey, we are excited to help you. So with that, hope you all have an amazing day and look forward to catching up with you soon. Thanks.
Bye.